Hello again, class. This next video is going to talk about the net ionic equation, and in your homework it asks you to write the formula for the precipitate formed. In our last one we talked about whether or not a precipitate is going to form, and we're going to tackle this one just a little bit further. First of all, you might remember way back, chapter 8, that we had 5 different kinds of chemical reactions, and one of them was a double displacement reaction. And this is one where we have two compounds, a plus and a minus, react such that the one will switch with the other. This is called a double displacement reaction. Now, one thing that we didn't talk a lot about but mentioned is that both of these are in a solution, and when they start out, they're aqueous. Like here's a test tube with some substance dissolved in it, and here's another beaker with the substance dissolved in it. They're both aqueous. Then they go into the same container as they're being poured in here. One of them potentially will become a solid, that is the precipitate, and the other remains as aqueous. It's still in solution. We could separate those by filtering out the precipitate or the solid through filter paper, and then we could get this to turn back into a compound by evaporation of the water, and then would turn back into a salt, just like salt evaporating on you when you have some salty water from the ocean or something like that. So fast forward to our current chapter 13, and you will see here at the beginning two different substances, ammonium sulfide and cadmium nitrate. And they have two different equations. One is forming these ions, and this one forms these ions. These are two separate dissociation equations. Really not forming anything new, just simply being dissolved in water. Your book goes on to follow the example here down to here. I'm going to take it to a piece of paper and show it to you that way. So here again are those same two chemical reactions forming 4 ions in 2 different containers. Now when we pour those containers together, all 4 of them are there at one time. So basically this part here becomes this part here. Now these are the reactants over here. And notice they're all in the form of ions. Now, the big question is, are any of these going to actually form a precipitate, which is something we addressed in the last video. And so the question obviously is, if these dissolve, then this one can't be forming with that one, so it must form with either this one or this one. Well, it can't form with this one because they're both positive, right? So the only option is it could form a precipitate with the cadmium and sulfide, or ammonium, obviously it ionized with this guy, so, or I should say dissociated with this guy, so it's either this one or this one. Well, it can't be this one because it's positive, so it must be this one. So those are the only 2 possibilities we're going to look at as far as whether or not we form a precipitate. Now, to check, we would go back to our chart and see which one forms a precipitate. Now, ammonium compounds right off the bat are all soluble. So if we have ammonium, could this one form precipitate? And the answer is nope. So it can't be that one. So then let's check for cadmium sulfide. Sodium nitrates, chlorides, sulfates, that's not sulfide. Carbonates, nope. Sulfides. Sulfides are insoluble. There are some exceptions, like the one we had with ammonium, but cadmium is not one of the exceptions. So cadmium sulfide is going to be our precipitate. These two are going to form a precipitate. So from these different ions, we are going to form a precipitate, and there he is, cadmium sulfide. Now, as usual, I have to double check my formula. Cadmium being a 2+, sulfur being a 2 minus, together they balance, and that is a balanced chemical formula. I don't need to make any changes. The nitrate and ammonium remain dissolved, and so we write those as AQ. Now, what do you call people that go to a sports event, basketball, football, whatever, hockey, and they watch the game but they don't participate? Those are called spectators. And so these ions here we call spectator ions. They don't get to participate. Notice there are ions on this side and on this side. So, what happens in math when you have the same thing on both sides of an equation? We can cancel them out. Not that they're not important, but we're going to focus on the cadmium sulfide in this case. So let's cancel out these two, and what are we left with? We're left with this equation where the cadmium, the sulfide, and the cadmium sulfide here, and we get what's called the net ionic equation. That's what that is. This here I should have mentioned, this is the overall. You will find it in your book right here, the overall ionic equation. That's what we just did. And then we have the net ionic equation. So the overall ionic equation, that has everything. And then there's the net ionic equation. And that's your goal here, to figure that out. Now, in your homework, it asks you here for the first question, it says, write the formula for the precipitate. And they give you two compounds, magnesium chloride and potassium phosphate. So you want to think of them as two dissociation equations and then figure out which two combinations might form a precipitate. Going back to your chart and looking up whether or not those form precipitate. On this part here, it says write the ionic equations or the dissociation equations for the following compounds. And that's just doing this part right here, those two things right there.